Hello everyone, this is Rap Structural View. In this video, we'll be discussing the expression of loads and conversion of expressed loads. Before we talk about expression of loads, we should first understand or know the types of loads that are available to us. We have dead loads, we have live loads, we have wind loads, and impact loads, and many other loads that we would not mention now. We wouldn't be treating the types of loads today, we'll be treating how these loads are expressed. These loads are expressed majorly as uniformly distributed loads and point loads. Then we also have two types of uniformly distributed loads, which are area loads and line loads. Now, as the UDL name implies, the loads are distributed, they are not at a point. Now, for point loads, it is assumed that the force is acting on a point. Though in real life, forces don't act on a point, they act over a particular area, which is why you see point loads are measured just in kilonewton. A great question will be, why do I have to know all this? Well, analyzing structures requires that you understand loads, how to convert them, and a few other stuff that relates with forces. Before we talk about area loads, line loads, and point loads, we must understand unit weight. Now, let's say, for example, you have a slab. Let's take this 3D representation as our slab. If you use textbooks like McKinsey, you'll find out that you are given something called unit weight. Unit weight is given in kilonewton per meter cube. Now, when I started figuring this out, what I did was that I would assume a small red box within the slab, which is functioning as the unit weight. Now, I know it's not realistic, but you can't blame a young man for trying to understand. And I believe this illustration might just help you too. Now, let's imagine that this red part of the slab that we cut out has a dimension of length is equal to 1 meter, height is equal to 1 meter, and breadth is equal to 1 meter. Well, here's what we're going to have. Well, we're going to have a volume of 1 meter cube. Now, let's say, for example, that specifications are given that this slab weighs 2 kilonewton per meter cube, would mean that for every 1 meter cube you have within the slab, a weight of 2 kilonewton is present. Having understood that, we know that unit weight is the weight exerted for every 1 meter cube volume of the slab, while area load is the weight exerted for every 1 meter square area of the slab. Line load is the weight exerted within every 1 meter span or space of the slab. And lastly, point load is the weight exerted at a point. Having known all this, how do we convert unit weight to area load, to line load, and to point load? Let's get to that. Converting unit weight to area load, our solid mass of iron has a height of 4 meters, length of 6 meters, breadth of 3 meters, and unit weight of 7.9 kilonewton per meter cube. Let's calculate the area load. We'll first find the total weight of the mass of iron. Total weight to be volume of the mass of iron multiplied by the unit weight. Volume will be length multiplied by the volume of this mass of iron will be the length multiplied by the breadth multiplied by the height. This will give us 6 times 3 times 4, which will be 72 meter cube. Notice that the meters also multiply each other as meter times meter times meter. That's how we get meter cube. You might think everyone would know that, but trust me, not everyone does. Now, back to getting our total weight, volume multiplied by unit weight. So our volume, which is 72 meter cube, multiplied by the unit weight, which is 7.9 kilonewton per meter cube. And the total weight is 568.8 kilonewton. Now, notice I wrote 568.8 kilonewton times meter cube divided by meter cube. I do that to ensure that I'm following how the units are going. And that's how we have 568.8 kilonewton. Now, we are going to convert the total weight to area load. How do we do? The area is going to be given as length multiplied by breadth, which will be 6 times 3 meter, will be 18 meters square. And we're going to divide our total weight, which has been gotten already, by the area, which would give us our area load. Our area load is given as 31.6 kilonewton per meter square. We have successfully converted unit weight to area load, given the dimension of the mass of iron. Now, let's see how we can convert area load to line load. This will simply require you to multiply your area load by either the length or the breadth. So let's take our area load, 31.6 kilonewton per meter square, multiplied by the length, which is 6 meters. The line load is going to give us 189.6 kilonewton per meter. Now, this should be noted that this line load is given across the 3 meter span. Now, let's go ahead to try multiplying the area load by the breadth. We're going to have area load is 31.6 kilonewton per meter square multiplied by the breadth, which is 3 meters. And we'll have 94.8 kilonewton per meter. It should be noted that this line load would be across the 6 meter span. Now let's observe the diagram that's about to pop up. Oh yeah, there it is. This diagram is illustrating the mass of iron being supported along the 6 meter span alone. Now this would mean that the beam supporting the mass of iron is subject to a load of 94.8 kilonewton for every 1 meter that the slab is resting upon it. Now let's observe the second possibility here, which is the mass of iron being supported along the 3 meter span. As we rightly solved, it will be subject to a load of 189.6 kilonewton for every 1 meter of the slab. Converting this line load to point load, we just require that you multiply the line load by the span across which the load is being exerted. Converting line load to point load, let's take the first one we got, that's 94.8 kilonewton per meter across the 6 meter span. 94.8 kilonewton per meter multiplied by 6 meters will give us 568.8 kilonewton. Notice that that is the total weight we got at the beginning of this calculation. And then for the second line load we got, that's 189.6 kilonewton per meter across the 3 meter span. If you multiply 189.6 by 3, you're going to have 568.8 kilonewton per meter. There again, we have our total load which we got initially. Now there's more to this when we start talking about two-way slabs and one-way slabs and how the loads are shared amongst beams that are carrying the slabs. But basically this does it. Now if you enjoyed this video, I want you to like, share and subscribe. Thank you. And yes, don't forget, hit the notification button right away.